Hello everyone. Now we are going to do this question, which is an electron of mass m with an initial velocity v is equal to v naught I cap. V naught is greater than 0. Enters an electric field, which is E is equal to minus E naught I, where E naught is equal to constant greater than 0 at t is equal to 0. So if lambda is its de Broglie wavelength initially, then its de Broglie wavelength at t is, so let's assume the wavelength at time t will be given as lambda is equal to h upon my mv naught. Okay, so we will assume this as the de Broglie wavelength at time t is. So here we can see that E naught is give E is equal to minus or E naught minus I cap. Initial velocity is equal to v dash is equal to v naught I cap. So force action on electron due to electric field will be F is equal to minus E into my minus E naught, which is this, into I cap. So the force will be E capital E naught and I cap. Okay, so this will be the force. Now the velocity of an electron at time t when Vt is equal to v plus At. So v is equal to means just a second, I will take a pen. Okay, so the Vt is equal to v plus At, which is v plus At. This is our formula. So from here we will find out the v naught plus E naught t upon my m is equal to Vt. So as Vt comes here will be the v naught plus E naught into t upon my m. Okay, now we are going to put this value over here, and it will be comes out to be this when we will calculate. So let's see what's the correct answer. Or no, it's yeah, it comes over the value of this when it comes to find out the value for lambda t. So the lambda t, just a second, lambda t is equal to this. So the correct answer, we will see what's the correct answer. Yeah, the correct answer is 1, which is lambda t is equal to correct answer which is given. Okay, thank you everyone.